These animations will be about a special kind of probability distribution which is called a binomial distribution. Binomial distributions occur when there is a series of events in which one of two things can happen, like when balls trickle down a grid like the one shown here. The results often look something like a bell curve. That is, the results tend to pile up in the middle. Some clever mathematicians figured out a way to describe this bell curve using a function. But it's a rather ugly function, as you can see here, or perhaps you think it's a lovely function if you're the kind of person who gets excited about such things. But in this course, we really don't care about this function. This is because we won't be figuring out probabilities using calculus, where you need such functions. Instead, we'll be using tinker plot simulations to answer the same kinds of questions. One reason why bell-shaped curves occur can be seen by looking at the paths that can lead to any given bin at the bottom of the grid. For example, at the first step, only one path goes left and only one path goes right. And again, at the next step, only one path goes to the two outside bins. But there are two paths leading to the middle bin. Then, at the next step, there are three paths that lead to either of the middle two bins. And, at the next step, there are 6 different paths that lead to the middle bin. 3 come from the left and 3 come from the right. But, there are 4 paths leading to the second and fourth bins. And, only one path that leads to either of the two outside bins. And, this pattern continues for as many levels as we wish. This triangle that is emerging is called Pascal's triangle. And, it's full of interesting number patterns, as you can see. But, we'll only pay attention to them in a homework activity. Here are some kinds of questions that we might ask about situations where the results are binomial distributions. 1. What is the probability that a given item will end up in a given bin, or in a given collection of bins? Or 2. If an item ends up in a given bin, then what is the probability that it came from one binomial situation instead of another? Tinker plot simulations are useful to investigate such questions. To begin, let's create a simulation that uses a spinner to behave like balls bouncing down a grid, turning either left or right at each level. In other words, we'll be simulating the situation shown here. And, we'll be running 5 balls through the grid. So, for this particular sample of 5 balls, the first ball went left and then right. The second ball went right and then right again. The third went left and then right. The fourth went left both times. And, the fifth went right both time. So, the first ball ended up in the middle bin. The second ended up in the right bin. The third ended up in the middle bin. The fourth ended up in the left bin. And, the fifth ended up in the right bin. But, there's an easier way to figure this out. Instead of using L and R, we can use 0 and 1. So, whenever we see a 0, this means that the ball went left. And, whenever we see a 1, this means that the ball went right. Then, when we run a sample, we can just add up the number of 1s to know exactly how many times the ball went right. Then, we can ask tinker plots to plot a graph to show us the results. Now, we're ready to run a much larger simulation. Let's run 100 balls instead of just 5. And, let's run them through 20 binomial choices. Now, when we run the simulation, the graph will show us exactly what % of the balls ended up in each bin. And, if we want to do so, we can run the simulation 1,000 times, or 10,000 times, to get ever better estimates for the probability that balls will end up in any given bin, or collection of bins. In the homework activities, you also can explore what happens when the chances of going left and right are not 50%. For example, if you just change the spinner, then you can set the chances of going left or right to any % that you choose.